Okay, so by the last week, up to last week, we're talking about the perception. Okay, so we're mostly handling about this part of it. Of course, it's not comprehensive coverage of all the perception issue. We're only talking about visual perception and audio perception in small part. Because we don't have much time to discuss many other things. So today's main point is this part, attention. So how the attention is working? So basically in visual information processing, when I'm looking at J1, am I right? G1, J1? J-He. When I'm looking at J-He, so I'm trying to filtering out all other students in here, right? So attention means some sort of spotlight. Okay? So I'm spotlight Yongjun, I'm spotlight Eunnim, okay? Such as, okay? So visual attention has a direction. What about auditory? Audio. Do we have a directions? No. Can we apply the same metaphor, the spotlight for the audio? Because audio is omnidirectional, right? Right? Am I right? That's why warning signal or warning information comes to your ear rather than your eyes. Right? Am I right? Sensible? Is it sensible? If the warning sign on visual information like red light, okay? So if someone looking at the different places, they may not notice it. That's why the warning signal is coming through to your ear, because that is omnidirectional. So there's a certain difference between visual attention and audio attention. So many of the study on attention go into visual perception, because visual perception explains many phenomena in information design. And now audio perception is also debatable and arguable research area to make a better information design, which means multimedia design. Technically speaking, multimodal design. So you have to know the word of a modality. Okay, when you make some information, you might need to use visual modality or audio modality, auditory modality. Okay, modality means some kind of channel you can use when you make information design, such as mobile phone. So major information on your mobile phone using visual modality, isn't it? Icon, label, right? Sometimes you can use audio sound, right? Music, when you play game, okay, music make you much entertaining. Okay, without music in the movie, if you see the music without sound, it might be really boring, isn't it? So that's why sometimes visual modality and audio modality must be mixed together to give information. That means multimedia is using our multimodality. See, normally visual and audio, auditory. So that means multimedia. When you make a multimedia information, you have to think whether these two modalities can give the same meaning. Do not make this information incomplete situation, such as truth effect. Okay? Truth effect is only visual modality. They do not use any audio modality. However, you can extend this truth effect using one information from your auditory channel, and the other one is the visual information, such as an example, say you're looking at red letters, okay, but on your hearing is something about blue. Right? If the information is different, visual information say red, but audio information say blue, you might be confused, right? So that's why the key design principle in multimedia is information should be consistently designed. But that is what we can do at the end of the lecture. But say something about today's part is how we toss the information in here to working memory. Without attention, okay, we can't toss the information in here into our major cognitive process. That's why the attention is important, and also attention is limited. We don't have much attention capability, which means we can't do much multitasking. So when I process Yongjun, I have to intentionally filter out other information, isn't it? So that's such a thing, say attention is limited, and attention pass the information through your eyes or ears into our working memory. So that's what today's topic. Okay, attention and performance, John Anderson. Okay, so what we start with, I'm trying to swap the orders. Our textbook is starting with auditory attention to interpret the filter theory and attenuation theory, but my suggestion and my opinion say visual attention should be first, and central attention and auditory attention might be minor issue. But that's why I've just swapped the order, starting with the visual attention, and then central cognition, and at the end, I will talking about the audio attention. Okay, bottleneck. Okay, so idea is we can't do multitasking. Can you? Have you done any multitasking? So your computer do some multitasking. What is the problem of multitasking? Anyone?
We can pay attention.
To one thing? Why that is a problem? So why do we have to multitasking? Why? I mean, you in your general life, in your normal life, do we have multitasking? Of course, you are listening to the music while you're studying, so that is multitasking. Efficiency, yeah, that's the point. So when you do multitasking, you probably believe I can do many things at one time, but actually the effectiveness or efficiency might be an issue. In our cognitive process, it's very similar. We can do multitasking, actually. Yeah. You can listen to the music while you're studying it. But whether that can improve your final exam score? What about this situation? I mean, that is a bilingual situation. When you listen to the pop song music, the pop music, or versus K-pop, while you're studying, because most of you are Korean. So which one is more intriguing? K-pop or American pop or British pop? Which one is more irritating? I mean, it's not irritating. It's kind of, which one could be an issue for the multitasking? K-pop or American pop? Huh? Well, okay, why do you think the K-pop is more influence or negative effect on our learning performance while you're preparing for the exam? Because that has the same code. K-pop is Korean code, right? Your preparation is also Korean code, right? The language. So if you're listening to the American pop, you might be filter out all the American things because you are focusing on your studying in Korean. You can easily filter out. That is only sound, okay? That kinds of things happen for my personal life. Say when I was in New Zealand, so been to many of the music. What is that? The cinema. There is no text line, okay? No caption text. So at that time, I can roughly say around 70 or 80% English. I can understand that. But when I watch movies in Korea, I couldn't hear any of the sound from the actor or actress because there's captions in there. The caption in Korean is much dominant for my language structure. That's why I couldn't listen any of the actor's speech or actor's word. because that text is dominant. Likewise, you may have some kind of selection. If some information is more dominant or salient, you have to pay attention to. You can't avoid it. You have to pay attention to it. So that's why when you make information, you have to provide the right information at the right time for people not to be confused about what information they are saying. That's the thing what we are talking about. So bottleneck, which means we may have a certain level of capability to do multitasking, but it could be a bottleneck. So that's why I'm talking about two different bottleneck situations. One is selective attention and the other one is focused attention. Okay, academically speaking, selective attention and focused attention have some difference, such as what is your goal. Okay, let me see this picture. So she is watching, she's looking at mobile phone, isn't it? While she is driving. She has a goal. What is her goal? Her goal is, okay, read out some text messages. Okay? When she has a goal, she selectively chooses the information, which means intentionally choose one of the information she has to process. In this case, she has to process road sign, road traffic sign, all the situation happens in front of a car, but she intentionally chooses to looking at the information. Selective attention. However, if this information is more important, because of the selective attention, she failed the task, driving task, isn't it? Get it? So selective attention is we select inappropriate information. That's why if you make the warning signal in a very different way, such as visual information on your screen, people cannot see it. Or if you make the information very dominant or salient ways, which is not much important, many cases, the error digester say, in that case, people is going to pay attention to the wrong information, so they made the wrong decision to do task. The selective attention is associated with the goal. User select goal to pay attention. Focused attention is somewhat different. Say, sometimes we are unable to concentrate on one information, which means this one doesn't have any goal. Okay? If something attention is linked to with the goal, it is selective attention issue. However, the focused attention is stimuli based. Okay, when some information comes in, okay, so I have to pay attention. So we have two brilliant students in here. So they made a very interesting example of game. What they made is relevant to your understanding of focused attention. Okay, I can show that they made a game. So basically saying this game is playing around to find him. Okay, you have to find him. Okay, when it started. Which one? Oh, this one? This one? This one? You sure? So what do you think? Say, okay, you are looking through this video clip to find him. So that means you are pretty much focused on this phase, right? But I try to make this game a little bit harder. Say, like that. Huh? Which one? Middle? This one? Middle. This one? No. Wrong. So why this one is difficult? Okay, so I'm not saying this one is what you have to play. Why the first one is easy and second game is much harder? Why?
The number of information has
Yeah, that's why our Sternberg, what is that? Paradigm is talking about when you have more information to find, it takes more time. Or serious bottleneck. So to complete this task, you have a goal, isn't it? To find him, the face. So that is limited. Okay, so because other information is too much confused with the other guy and that is all masked one, so that you forget and the moving is really fast, so that even though you can pay attention to this whole information, but you couldn't follow the information you want to looking for. Another thing, so, okay. Another thing is talking about the selective attention. Okay, this game. So you have to avoid the push pin. Okay? So there's a couple of balloons is playing around in here. Go. So there is a push pin in here. The balloons in here, so you have to avoid it. To popping. Okay? So within 8 seconds you have to, okay. Am I good? Very good. I love game. Okay, the next level is much harder. So we have more than one. See? I told you I'm good at game. See? Okay, so you see the two different levels. A third level is really hard. I couldn't finish it. Okay, so the first level we have only one push pin, right? And second one we had two push pin, right? So which one is more difficult? Of course the second level. Why? Why the second level is difficult? Number of information
increased.
Okay. Okay, so more technically speaking, so we just learned about selective attention. Using selective attention word. If you want to complete this game, you have to systematically use your selective attention. Sometimes one of the button A, the push pin A, sometimes push pin B. So you have to pay attention to either of to avoid your balloon. So that's why most of the game design is using many of the psychological understanding. Of course, third level, you might put more pins. So which means people have to pay attention time slot. Okay, you have to make time slot, 3 time slot. Okay, first time is push pin A, push pin B, push pin C. So if you have more pins, it's much, much harder. Human cannot handle it. But some people can do it. My boy, he's expert, so I mean that is a motor skill. So motor skill and this cognitive skill is somewhat different. So we just find it later on. But likewise, many of the example application is using the focused attention and selective attention. Say that is what I'm saying. The serious bottleneck in there. Oh, another thing. Okay, so. Which is very entertaining example 2. Okay, so this one is another video clip from the Simon's lab. So instruction is what you have to do is count how many times the player wearing white pass the basketball. So what I'm asking you is this group of people count how many times they are passing through the basketball, each other wearing white clothes. Okay? And the rest of the group is looking at the black colored clothes people. Okay? You're just only looking at white people. You're only looking at black people. Okay? Black wearing. Okay? Try. Okay. You white, you black. Okay. White, white, black, black. Okay, keep. How many times they are passing? How many times they are passing? Okay. Okay, wait. How many times they are passing? No? 13, 15. Okay, wait. Don't say anything. How many times? 21. Huh? 21. Okay. Okay. Have you seen the gorilla?
Yes.
All of you? You never seen it?
I've seen it.
You seen it? Anyone wants to see gorillas? Never seen? All of you have seen the gorilla? You haven't paid attention to the game, so. What about you guys?
Yeah.
Have you seen the gorilla? So the experiment in here was, the point about how many pairs did you count is not much important. When you pay attention to the white people, you may not see the gorilla, right? But you all see it, which means you are now paying attention to the game. But when you're looking at the black people, because one of the gorilla is black wearing, right? That's why most of you will see the black people, a black gorilla. You haven't seen that, okay? It doesn't matter. So the controlled experiment say when you pay attention into one information source, they are filtering out the other information. In these cases, in this group of people, when they're looking at only white information, they are intentionally filter out all the black information. That's why they might not see the gorilla. But in this case, your job is to focus on the black one, right? That's why you will see the black gorilla. Okay, that is about, so it doesn't matter. Well, that is kind of example. It's a understanding what is focused attention things. Okay, our textbook is before John Anderson talking about the selection theory, the attentions. He mentioned about two major theory. One is early selection theory and late selection theory. The idea is very simple, say like this one. In this our major model, when information is filtered out, here or here? Okay, here or here. The only difference is early selection model is when the information comes into your eye, you intentionally filter out the information which is not relevant to your job. And second approach is it goes through somewhere in here, stay in here, but your central cognition is pick up the information things around this stage to move into the working memory. So this applies to visual information processing as well as audio information processing, but that much relevant to the audio information. That's why our John Anderson using theory explanation before he talking about audio attention and visual attention. That's why I just swap around the information in our textbook. Likewise, explain what is this, and then I go into the visual attention. Okay, so you remember that there are two selection theory. So all the selection theory is filter out all the information before we perceive the stimuli. Late selection is we all perceive it, but later on we are picked up. Okay. So I mentioned about endogenous and exogenous approach. So goal direct factors are selective attention, and stimuli-driven factors are focused attention. Selective attention is relevant to your approach when you have a goal, like a mobile phone. You intentionally choose one of the information source. Okay? However, focused attention is different because the information is so salient, so I cannot avoid to filter out this information. Likewise, warning sign. Okay? So all the visual attention textbook is talking about visual attention is about spotlight metaphor. Okay, spotlight, you know the spotlight? Okay, like lantern. So when I use the lantern to, what's your name?
신차오.
창업.
Yes.
When I use a torch to him, say, which means I can only focus on the 창업, right? So that is how many textbooks talking about spotlight metaphor say we can move our attention to focus on various areas of the visual field. Okay, so I'm just look through it, okay, which means I'm just looking around you guys, each of you, and we can span from small area or large area. Pretty much good approach. So sometimes I can focus on one of you, or sometimes I'm looking at the group of you guys. Narrowing the spotlight gives maximal processing to that part of the visual field. Say, when you need to process the information, like reading a book or reading a newspaper, you need to pay attention to a certain area. Of course, you can read the whole section, just skim read it. But when you actually understand or comprehend the meaning of the text, you have to find a very small area to read it. Okay, so we have to extending or narrowing down for visual attention. But actually, for the focused attention, to find the right information is needed. So that's the what spotlight metaphor say. To understand the visual perception, in particular selective attention, I have to explain two different concepts of our visual sampling. Okay, we are sampling. To process the information, we have to sampling it. Say like, when I look through this whole classroom, I'm just sampling it. Okay? I'm not counting each of you guys. I'm just sampling around, around 15, around 14, okay, around 15, something like that. So I have to sampling it. For the visual sampling, we have two mechanisms. One is pursuit movement, your eye following up some information. Okay? Following up the information. And second one is saccadic movement. Saccadic movement is jumping from the information to here. Like when I look into Yongjun, next time looking at Ini, am I right? Yeah, Jay, sorry. Yongjun, Jay, and someone like that, jumping around. That is called the saccadic movement. I made a slide, like the first one is saccadic movement. You're looking at this information, and then, see, your information, your visual focus starts from in here, and then there's no information, and suddenly information comes up in here, so your eye moves from here to here, right? Quick moving, very quick moving from one point and the other point, without any following. Of course, there is no followings, but pursuit movement is this one. See, there is information here. Now you're doing the pursuit eye movement. So you keep following the information sources. Right? Okay, that is the difference between pursuit movement and saccadic movement. Okay, question is, when you're reading a textbook, what is your eye movement? Saccadic or pursuit movement? What about, okay, there's heaps of people there, okay? So trying to find your one of best friend, what eye movement are you using? There's heaps of people out there, so I have to find my best friend. So what eye movement are you doing? Both of them? Pursuit? Step by step? I mean, everyone from the left top to the bottom. You can do it. It takes time sometimes. We are mixed them together. So sometimes we are using the pursuit eye movement, or sometimes you also can apply the saccadic movement. However, context can help you. If your friends are girl or female, right? Even though there's heaps of people, you can use a saccadic movement to find only female, right? You don't need to follow everyone. Right, there's mixed up the man and the female. So in that case, if you know that female is your best friend, you only saccadic moving to find your girlfriend. Of course, the other way around is the same. Okay, anyway, that's not what I want to explain. We are using these two different eye movements to find the information source. That gives many different approaches. This one has not been covered in our textbook. That's why our slide doesn't say about Anderson's the footnote. That's my slide say, because of these two different approaches, two different eye movement, we have two different types of visual sampling. One is supervisory control visual sampling, and the other one is target search. Okay? So these two are slightly different. Say this one. The first one for supervised control is using pretty much pursuit eye movement. When you do monitoring all the situation, like you, as an industry engineers, you have to monitoring how the plant is working, right? Production management system, right? In that case, you have to keep monitoring it, whether there is any inventory left over or whether you have to order the work in process items. So you have to keep looking all the monitors, right? That is supervisory control. In that case, one of the design guidelines say 1978 Posner something say sampling channel with a high event rate. The idea is very clear. Say, if you know when this event happens, they can look into it. So for example, you already know as a production manager or production control system, every morning our company will have some shortage of the work in process. If you know this knowledge, every morning one of you, your operator, you guys can looking at this event. They are intentionally sampling more information in the morning to find any shortage. But if this event rarely happen, you forget it. Do you know what I'm saying? Say, this event, if never happen in your lifetime, you are not much possibility to find this information, even though designer made it. That's why what he said is our visual search is depending on rate, probability. Difficult, isn't it? Someone? That's why, say like this one. In your mobile phone design, what is the most frequent one? Frequent function you're using it. What is your most frequent function you're using in your mobile phone? Phone call? KakaoTalk. Okay. That's not what I want to hear, but I mean, that is application, right? Mobile phone. It's the most important function is calling, isn't it? Calling is the best. Best? You don't have much money, right? So that's why you use the KakaoTalk for free. Okay. Anyway, the phone call is the most frequent one, so that's why we can make a bigger icon for calling. Why? Why? Why we have to make a bigger icon? Easy to use. Why that is easy to use? Sampling. Because we can easily notice where it is. Our visual scan, visual search, your eyes can easily detect when the icon is big. Of course, that goes into the center of it. Say like, I mean, that is nothing. Anyway. So we just skip this one later. Okay. Okay, another one for the target search, using saccadic movement, and another terms you have to remember is UFOV, useful field of view. Probably your human factor studies can teach you about the UFOV. So it depends on who you are, so your UFOV is slightly different, but majorly in commonly sense, say some angles we have for the visual field, useful field of view. And other information in here, even though we can see it, that is peripheral information, which means not much processed it. We can process certain information around in here. Okay? And novice and expert, the beginner user and expert user has a different target search because expert knows sampling process. They know where have to look at. in production systems, so for example. But novice doesn't know, so they have to scan everything from left to the top left to the bottom right. Okay, that's the difference between when you have a practice, when you have automaticity, when you have expertise, you can have best channel, best visual sampling channel, like what mental models say. The mental model say everyone has a different mental model. Your mental model and my mental model is different. Okay? So when you have expertise to do some tasks, you can have certain mental model to do some task effective ways. Okay? Hang on, I can explain the sampling process. Expert and novice user in here. Here we go. This one. Okay, this expert and novice users different mental model is really important. So Rasmussen in 1983, he proposed the SRK framework. Okay? The SRK framework is that. So when we are expert, okay, when you have expertise on do something, that could be a routine task, right? So like eating food, you are expert, right? Okay, eating food is your expert. So that's why the routine task has a skill. And novice user, okay, someone who doesn't know how to do the task, they have to use the knowledge. Okay, idea is this one. To understand the SRK, just imagine that you are the driver, the first time driver in your lifetime. So how do you get from your home to school? Anyone have a first driver? License, driving license, but has a couple of driving experience. Anyone? Anyone? You have a driving license? Have you driven actual? Okay? So how do you get from your home to E-Mart or something? You remember most of the things, right? So you have to, trigger the wheels and change the gearbox. Okay, you remember everything, right? But when you get used to it, like me, I never know how I started from my home to the parents' home because I'm just driving. Okay? Am I right? I'm not never know how I did it, but just did it. That's why when you have an expertise, okay, that is skill, which means your attention level is minimal. You never attention to the skill levels of tasks, like eating. Have you paid attention to for your eating? Okay, eating is just a skill, right? But when that is a novice situation, like what? Okay, driving is the one. Very new situation. Oh, such as you bought a new mobile phone, new device. Yeah, for example. But you never know how to use it, right? Because that's a totally new one. In that case, how can you use it? You have to read manual. Okay, that is this one. It cannot be done with your skill. You have to have certain knowledge. Okay? So because that is novice situation, a totally new one, so to complete this task, you have to acquire certain knowledge from the manual. That's why this SRK framework is being used in education program. Skill challenge balancing approach. Have you heard about that? Skill challenge balancing. So when you do some e-learning or skill challenge balancing approach is also can be seen in Super Mario. You know the Super Mario game? Game, right? The big one, the mushroom guy. Huh? Mushroom, it looks like mushroom. Okay, so when you do jumping like that, probably they have some route is that, right? Sometimes they have a very small jump, okay? and then a little bit more jump, and then the last one is a really, really big jump, right? Couple of times jumping up, right? Am I right? You never played this one? Okay, something like that. So which means this game designer is know that this paradigm. Okay, until they reach to the final hurdle, they are practicing in here. Okay, so in the beginning, very small learning, okay, just small learning. And the second one is a little bit harder. And the final one is a big, big one. So that's why the game designer knows this SRK framework to starting from knowledge. Okay, starting is knowledge. So because they are calculating their fingertip movement, we have to, otherwise you can't finish this game. So that's why you have to build up your knowledge using a couple of exercise, and then probably you can generate a rule. When I see this second hurdle, I have to hold down this button a little bit more, such as 1.5 seconds, roughly. Okay, and then I can finish it. That is your rule. Okay, the first time you develop your knowledge, and then when get used to it, you make a rule. When something happens, the mushroom guys, so they have to jump with the X and Y button or hold at the same time. That kind of rule, you generated it. And then, finally, when you get used to this game, they never know the rule. They just do it. Because that is all skill. Your finger, your motor skill, remember how you do your game. That is all your skill. That's like eating, breathing. Breathing is a natural thing. Eating, studying is your skill. I don't know, it's something. Game, game is a skill, of course. Yeah, certain things. Driving, expert driver. Okay, expert driver is to develop a skill. And this one is education program, for example, nuclear power plant controlling. Okay, when they have to make a certain operator for the nuclear power plant, they are teaching heaps of knowledge. But when getting used to do it, they don't remember all details of knowledge, but they just running the reactors with their skill. Point is, most of error comes from this part, not from this part. So when you have a novice user, you are very careful. So that means you pay attention to certain information. But skilled user simply many times ignore the important information. That's why they are educating more time the skilled user given new situation. That's how the simulator is working. That's why the pilot have an annual training session, even though they are skilled pilot. Because most of the errors comes from the skilled level of user. Because they are not pay attention to the information. Because your finger remember the actions, reaction, like a robot. Okay, that is how the normal attention happens. So we go back to the slide relevant to our textbook. Okay, so our textbook is nice and Backlund experiment in 1975 is 2 tasks. One is this one, and the other one is this one. So frames from the 2 films used by Nice and Backlund in their visual analog of auditory shadowing task is about, idea is simple. When we have seen the 2 video, the kind of things, you are being asked to focus on this hand clapping. Okay? But the other group is only heard, only told, they are looking at these ball passing people. Even though we are overlapping these 2 pictures, 2 frames, the people can finish their jobs. Which means this group of people who are heard about, they have to looking at this only ball passing people, they can see this picture. The group of people in here who have to told about see the hand clapping people, they can see this one. Which means we can pay attention to one of the important source, intentionally filtering out the rest of the information. That's how the Nice's experiment. Nice's experiment is talking to us. Example like that. Some people can see the picture, the house. Some people can see the face. But even though when I ask some of the group to only looking at the face, they can do it. And the other way around is the same thing. When I ask you something about looking at the house, you can do it. And our textbook also say, depending on your neural process in your brain, okay, you may have a different part of your brain is activated. We are not going that much further, but I mean, the John Anderson talking about to process the face, they have using a certain part of your brain. To process the house, they are using the different part, which means attention might be separated resources. It's not saying one part of the brain is not for all attention one. Maybe our brain is working for process the attention in very different ways. That's what John Anderson is using his neural network, neural cognition approach. So I skipped this. That is what the Megan and Hilliard and Locke says is that they're using the fMRI scanning to find which area of the brain is activated. Okay, I can skip to the next one. That is the kind of Steinberg paradigm thing. Say the visual attention, our visual search is, okay, so this one with an example. Okay, so this one is stimuli given by the experimenter, and then they have to find the K. Okay, okay, so that they are looking from the top to the bottom. So intentionally they put the K in the different row. Okay, so that's what they have found is this one. If the K is located in the first line, first row, they can easily find it. But if the K is located at the bottom of the line, it takes more time, which means our visual search is supervisory control from the top to bottom. We are not doing saccadic movement to find the K. Because the job is to find the K, our visual search path is top to bottom. That's why implication. What is the implication of this visual search path? Most convenient or most frequent icon should be go top left. Okay, that is the design principle of Mac. When you do the Macintosh, see, I can make this one is mirroring. That is start button. In Windows start button, where is the Windows start button? Bottom, isn't it? Apple has the top left. So that is start button. All the major things in here, shutdown and things. That's the why the Apple's design philosophy is following these kinds of understanding. Okay, top to bottom. Okay, this one is feature analysis thing, which we mentioned last week. And Treisman and Gillard is 1980 pop-out effect. Okay, the idea about this pop-out effect is distinctive targets tend to be much easier to find in a display than when they blend with the context. Idea is this one. Their experiment is this one. Okay, the A figure is the major job. Their task is finding T. Finding T. Okay, and then one group of users have seen this one. And the other group of users have seen this part, right? And then they are collecting the responding time. Responding time. So which one is much easier? Which one is difficult? Which one is easier?
B.
Why? Why the B is easier?
Because in the case of A, Y, and T has similar shapes, so
Similar shape, technically, because you learned something about feature analysis last week. Say Y and T share vertical line, isn't it? So they have a feature, same feature. Of course, I also had a vertical line, but we don't have any horizontal line in this picture, isn't it? Am I right? Look at the jet, the figure B. In a jet, we have horizontal line, the feature, right? I has a vertical feature. That's why T is sharing all the features with the jet and I. So when you look at that, response time is increased in when the I and jet is dead. So visual search is, the idea about this experiment is supporting people using feature to recognize the visual information. Of course, it's supporting evidence of the previous visual perception thing. And binding problem is the really difficult concept. So that's why in week 6, before your midterm test, we don't have any midterm test. Did I say that? The essay is covering it. Your essay, I will give 2 more essay until your midterm test. So that covers your midterm test. So you don't have any midterm exam. Anyway, the binding problem is linked to the working memory, which we will discuss in week 6. Okay? The binding is issue. So the question of how the brain put together various features in the visual field. So we received many information, okay? And how that is actually processed by what? So that is central cognition. So that is covered by our working memory capacity. Okay? The feature integration theory. The feature integration theory is people pay attention to on stimuli before they can synthesize it featuring into patterns. Okay, this theory is combined with illusory conjunction. The idea by illusory conjunction is this one. Okay, so there is a pink K, the K letter in pink color. Okay, pink K, and red R. Okay, red R. So you have heaps of the text with the colored one in here, right? And then you're just looking at them and then just screen down. When I ask you whether have you seen pink R, many of you will see, oh, I have seen the pink R. Many of you, because you haven't seen the pink color, but you haven't actually processed that is K or R. Okay? So idea about this illusory conjunction is, even though you haven't seen the information, your brain process it, it looks like you have seen it. That is called the witness theory. In the week 1, I mentioned the witness theory, isn't it? Your witness, the car accident witness, they intentionally make a story, even though they haven't seen it. You know? If the BMW and Tico, or the smallest car in Korea, the Morning, if they are colliding each other, many of you will say, that is problem of BMW. Because Tico people, I mean, there are people who has a smaller car, they are not speeding out. Normally BMW or speed car, like a Ferrari or something like that, if there's 2 colliding it, even though the fault from the smallest car, many of you will say that problem comes from this Ferrari. Because Ferrari is faster. Okay? So that kind of your interpretation in here is intentionally ignore some of the information. To avoid this kind of situation, feature integration theory say, when you need to process the right information, you need focus on the information. How? That is your job. Information designer and industrial engineering designer must provide how people to see the information you want to make. Okay, you can make any information, but your information must be seen by the people, right? Your user. And then that information must be salient or color coding in using any other approach for people to recognize it. If that is so much important. You get it? So that's why if you believe this information is critical in controlling system, you have to provide certain extra dimensions, such as using auditory information like a signal or blinking, if that is important, to pay attention to your information. Am I right? Or color coding, or big size. Okay? In any cases, you're using every possibility to let them know this information is critical so that they can pay attention to your information. The major dilemma in any the information designer is that they keep talking about, okay, I made something for you. Okay, I made all the information you need, but actually that system is failed because people never see that information. If you believe you want to show this information is really important, you have to make this information for people to see it. Salient. Okay? That is how all this figure integration theory and illusionary situation happens, because people sometimes you recognize some information even though that has not been happened. Okay, that is the second part of it. Okay, so I can move into this one. This one is visual search, but however it's not much relevant to the saccadic eye movement, but our textbook say that this patient has some right hemisphere, the damages. Okay, right hemisphere. So when you go back to the last week's lecture about vision system, okay, the right hemisphere covering up what side of world? Left side of the world, isn't it? So that's why these people is asked to strike through all the circle, right? But she failed some part of her right brain, right hemisphere. She didn't recognize this part. That's why she couldn't do strike out. Which means for the attention, pay attention, this both of the brain is working. In particular, visual attention, this part is covering the left side of the world, and this part is covering the right side of the world. So that is an example about we have separate area about visual attention. Okay, so that's the thing our textbook say. The last one is, hang on. We can come back to this topic later, but before we going, so I'm trying to go talking about inhibition of the return. Okay, this one is the last topic of today's lecture. Say, inhibition of return is to increase our visual search effectiveness. Idea about inhibition of the return is, when I'm looking some information from in here, such as trying to find my best friend, I am not go into the same place twice. Okay? So when I'm looking at in here and then moving here, I'm not going into back in this part. So that is kind of idea is the winners taking all effects. Say, if you want to find your best friend, you're starting from the top left, okay? And that is your path. Okay, and trying to go to the next spot, and then moving around, right? And then suddenly you found your information here, so they just take out all stuff and they never come back to the same spot to look around. Which means, say again, they look in here and then here, they never come back to in here because they already searched it. That's why in nuclear power plant digesters, if the information is located in here, but they missed it, they never come back to that information for the time being. Okay, so that is human behavior. Humans want to increase their effectiveness of the visual search so that when they see one part of it and then go to the next, and for the time being, they never come back to the original source. Okay, that's why we sometimes miss the many information. Okay, this one is explained tomorrow. Again, say with the other example, how the IOL, inhibition of the return, make effect on our information design. Okay, that's the end of today's lecture, and then I'm coming back with this object recognition things. So tomorrow morning. So, any questions? No? So you're free to go then.